All right, to pick back up from where we left off, we've got our rough wireframe drawn around the payloads. We kind of have an idea of what our vehicle should look like, even in 3 dimensions. I mean, you can kind of develop a mental loft of what we're talking about here. Flat wing, no dihedral. Hopefully it'll be a bit more stylistic as we progress forward. But in this video, we're going to finish the fuselage. We're going to do an actual detailed loft and actually start to get some actual skin dimensions or shape definition for this vehicle. And the interesting thing we're going to do is it's not going to be a part of the assembly. It's going to be a new part. So instead of insert components and you browse for a part that you want to insert, that would be kind of a headache. I want to be able to draw the loft around all these internals that I've laid out. And again, just as a reminder, you should lay out your systems, meaning servos and batteries and whatever other payloads or receivers, electronics, everything system-wise should be here. That is going to dictate the geometry of your plane. Do you need to model every wire at this point? No, definitely not. Do you need to model little control rods? Probably not. But anything that's bulky, big, you have to fit into the airplane and fit around would be advisable. So let's go ahead. Let's create a new part. Yep. Inside the assembly. Yes. What? Why? What is it? It did not make a new part. Why did it not make a new part? New part. Oh, okay, it probably wants a plane reference. Oh, right, there we go, there we go. So now we're actually in a new part. Okay, my bad. Yeah, you can't just click the assembly, you have to click a plane. Awkward pause will stay in the video. Whoops. So anyway, the part is just belovedly called Part 5, but you notice the blue title and the blue elements are now actually live. Everything's else is kind of grayed out. There's one other big and important thing that's happened here is this No External References button is clicked. I would advise you to leave that on. Because that means as you're working, you can't accidentally reference something to this, wireframe sketch we had before. It sounds like a good idea until you think that everything on the plane might be slaved back to that. And if one of the linkages breaks, which SolidWorks admittedly is not the best at maintaining, if something moves too much and it's displaced an inch from where SolidWorks thinks it should be, it sometimes will just break the link, and then that could break your entire airplane. So I want to have all of these sketches we're making here independent of one another. So leave that on. We're editing a component inside of an assembly, which means an actual individual part. There'll be no external references placed there. We're inside of a sketch on the right-hand plane of this part. So just realized I'm in the wrong plane. So anyway, let's exit that sketch. I'm going to be doing this on the front plane. Oh, it's rotated. Well, that's annoying. Okay, we're going to exit the part then. We're going to delete this part because it's not configured the way I wanted it to. Okay. I'm going to be drawing the fuselage, right? So this is a big component. I definitely want the orientation to make sense. So let's do this again. Insert component, new part. Click on the front plane of the assembly. So I think that should also now create the front, top. Yes, so now it matches. Okay, front, top, and right of the fuselage. What's going to be the fuselage part will match that of the assembly. Okay. Let's make, not a sketch first, but a series of planes that are going to define the stations of the vehicle. So a plane here at offset from, this will be the origin. So let's offset from that back approximately, 6 inches? Oh, other way. Flip offset. That'll put it kind of at the front of the passengers. I guess I can just drag this, do it the other way. Oh, what? Come on. Yeah, welcome to SolidWorks. Sometimes you hate it. Really? Okay, it added this thing as a second constraint. I don't want that. On a pure offset, all right, let's move it with this arrow that... Okay. Thank you, SolidWorks. You can adjust it with the text. 4.5 should move it forward, other things should move it backwards, and so forth. I want to actually leave that right at 5 so that it's right at the front part of the passengers, which is really the first cross-section of significance for the aircraft. And then you go through and make some other planes at various other locations. Instead of 5 inches, put this back to 12. Just clicking another field. I have to flip the offset again. Yeah, that's a bit too far back. Let's change this down to about 10 inches back. Nope, too far forward. Just right. Okay, so that'll be the aft portion of that payload, which will be this kind of the second critical cross section. And then at the very, very back of the plane, without going to the very back, for reasons you'll see, let's actually create something. Let's see if I can use this arrow. I should be able to use this arrow. But, you know, that's how everything works. Okay, let's go back 24 inches. Is that a good enough guess? No, much too far. 20 inches. Nope. It's a shorter airplane than I thought. Okay, 16? Still too far. I'm really bad at guessing. Oh, I know why. Because I'm not doing it with respect to the front anymore. It's just doing it based on series. Okay, so let's do it front plane, geometric offset. That's actually a bigger error than you might think. You want each one of these planes to be defined by its location relevant to the front of the aircraft. So let's see if my guesses make more sense now. Yeah, they do. Okay, so the initial one of 24 probably works. Yeah, I want to go actually a little farther back than that. 26. Okay, let's fix this plane we did here. So we actually have it relevant or related to this previous plane. I don't want that. I want it to be related to the front plane in that subassembly. Not 11 inches back. Now let's do about 16 would be a decent guess. Yeah, good enough. All right, so now all the planes should be related to the front. And the last one they need to make, that maybe should have been the first, is related to the front. I want to go back maybe even just half an inch. And the reason for creating this will become apparent shortly. So this is where the advisement, maybe you heard in a previous video that you've watched here, that you're just drawing half the plane at a time, is going to become evident. We're just going to draw half the fuselage cross-section, each one of these major points. Let's start with the ones that are most easily defined, namely the back of that payload box and the front of the passenger compartment. So I think it's wanting some rebuild here, so we'll let it get happy about that. So on plane 2, let's do a sketch and go normal to the sketching plane. And so now you have to think mentally that this blue box, the sketching plane you're on, is actually slicing through the part of the plane where this, what is that, green, teal? I don't know. Where that's placed. So with a spline, let's more or less conformally go around that part. So it's nice to have kind of those 12 o'clock and 3 o'clock nodes, as well as a node here that defines the actual corner you need to travel around. And then you get the 6 o'clock point as well. For this 12 and 6, I like very much, because those are going to be your seams, just make it easier on yourself by having those horizontal. That way you don't end up with a very obvious seam right down the middle of your airplane. This node would also be very easily placed as vertical. I mean, it just makes sense to have kind of this symmetric airplane. No reason that you couldn't do otherwise, but yeah, we'll do that for now. Let's just adjust these tensions to the shape. Gets positioned as you like it. Make it look nice and aerodynamic. This is where kind of some of the style and some of the character of your plane comes up. In fact, here towards the back of the airplane, we don't necessarily have to go around this payload element. That could be up farther forward. The payload compartment could be wider where we're carrying the people, the weebles, but narrower back where you're just going around a box. Now, here's the thing. You don't want to take this fuselage right down to within 1/100 of an inch of your payload. Because keep in mind, as you make this part, this is the outer mold line. So you have skin thickness, you'll have some composite material thickness, you'll have some inaccuracy of part production you really, really, really should account for. Plus the difference in drag from here to here is not really a big deal. So make sure it works, first of all and foremost, please. Let's not go too wild on minimizing things. Let's give ourselves room to grow and to adjust the airplane as necessary. So that's one cross-section done. You can see it's positioned back in a decent spot, and it doesn't even really match the initial concept sketch. From looking at what's carried internally, I don't have much of a reason to match that internal concept sketch. Now, am I missing things in this assembly setup? Yeah, I was quick, and I didn't draw my receiver or battery pack or other important things that I'm sure you will have done by this point. You notice I keep reminding you about that. All right, so let's go up here to the passengers, draw another sketch there. I'm doing exactly the same thing, just taking into account now that I'm focusing more on these passenger spheres instead of the green box in the background. So let's go ahead and do another spline. You know, it'll be a little bit shorter up top. Let's, in fact, I think I'm just going to do 3 nodes on this one. A little shorter on the bottom. These left and right ones should still be horizontal. I shouldn't say left and right. The left to right joint should be horizontal. This one will be vertical. So really the angle is not that critical. I'm just going to be adjusting tensions to get the shape that I want. I mean, that seems fine, right? I mean, spheres don't need leg room. Good enough. All right, so those 2 cross sections done. Now the more awkward ones. Let's go to the back. That's not the back. The back one. And you'll see now we actually start dictating what the back portion of the plane is going to look like. And maybe I need to kind of slide this around to see what I want to even draw. So we're in that plane. It needs to be higher, because keep in mind this dotted line here is the rotation angle. So really I need to stay above that origin, roughly where that line's at. And that's very hard to see whenever you're orthogonal to the plane, right? It just all disappears. It gets stacked up right here on the center line. So let's just guess, check, move. That's why CAD's nice. Okay, doing that stuff still for the same reasons of the boundary in the middle. I will keep those top and bottom bits horizontal. Keep this one vertical. Give it a little bit of thickness, because thickness is structure. Actually, yeah, bring this out decently. Good enough. How are we doing vertically? Oops, yeah, I exited the sketch. That's not bad. I'm going to go with it. Close enough. You can adjust it later if you need to. Right. Do the last one, the front one. Save. Gosh, save this stuff all the time. So in the front element, do a sketch. And in this case, I'm just going to do actually half circle. I do want it to be almost a perfect circle. Nope. There. Let's go with a size of, I don't know, 0.7 inches. Something small-ish. And that'll let us have it kind of this nice, perfectly radial nose. Center line from top to bottom. Trim that off on the left-hand side so that stays with the same like hemispherical construction we're doing on the other sides. There is something to be said about preserving the same number of nodes. Like this first one we drew has 1, 2, 3, 4, 5 nodes. The second we drew had only 3. The back one has 3, and now the front one only has 2, the stop and the end. We'll see if I'm doomed because of that, but I think we should probably force something to work out. So this is the part that actually now starts looking really cool. You've got your cross sections drawn, and then this is kind of the rewarding bit that you go to surfacing. Again, if that's not turned on, right click, make sure the checkbox is there. And let's do a lofted surface going from the front, which you notice is not necessarily closed, to the middle. Okay, good, those closing points are on the same side. One further back. Oh, see the crossing points are wrong, so I just click and I'm dragging it around. Okay, now you see it starts to look like fuselage. And let's get the back. Again, it's wrong, so let's put that on the right side. And it looks like a terrible banana. But hey, it's not horrible. It's pretty neat for being such a quick effort. There are several things you can do here. In fact, there's nothing saying you have to do all of this in one go. In fact, I'm just going to keep this first one simple. That's going to be the first loft. I'm going to go ahead and hide it. In fact, I can change it, make it a color. Yeah, let's do that. Let's make this surface some horrendous color. Yeah, that's pretty bad. Let's go ahead and hide it. I'll make it reappear later. Suppress. I thought I'd just hide. I just want to hide. There we go. Hide. Okay. What I'm going to do, though, is use the exact same sketches to do this in stages for a different option. And you'll see, once I show both of those in a minute, you'll see where they overlap, how the shapes are different. You can make choices on how to do this yourself. And it really shows that there are many different ways to do this problem. So if you just select 2 sections, it's going to be a linear interpolation between the 2. It's very easily defined. And not a big deal at all. So yeah, let's create the first section like that. We're going to add on another lofted surface between. Oof. This is where excellent naming or excellent memory of these sketched elements comes in. So let's go from that sketch to that sketch. Okay, it's closes out. Now this is where something nice can happen. Like if you just did this with pure linear segments, that looks like garbage, right? You have a straight segment, a chop, a straight segment, a chop. It's going to be like you did some sort of foam wire cutting. You can do start and end constraints. So at the start constraint, you could, if you wanted to, make it normal to profile. That just makes the departure of the surface from this sketch normal to the normal vector of the plane it's constrained to. Now, let's not do that. Let's say none but the end constraint. Oh, I see my second mistake now. That's okay, though. You can learn from it, and then I'll go fix it. The end constraint could also be normal to profile, but what I'd really prefer, even though that's a bit better, is that it is tangential to this surface that it's attaching to. So if we really zoomed in, you'd see that there is some minor angular discontinuity there. Okay. Air doesn't like that. Air wants to be smooth. So even though this looks okay, yeah, we can make it better. All right. So instead of selecting sketch 3 as a second option, I'm going to select this edge. Sketches do not contain directional information. Edges do. So by selecting the edge now, you see we get another option here where it is tangency to face. So that means now it's going to leave tangent to this surface that's already created. Or sometimes you can even get it to solve and be curvature continuous, which you see the difference was minor. But this is basically the difference here where it's first derivative continuous. This is second derivative continuous. So that's pretty neat. You also can control, you should be able to control, yeah, tension. So if you want to make that, well, yeah, too much, stop, okay, right, that's not good. If you want to make that more influential, so the tension of that connection changes the shape of the loft much more substantially, you can do so, or you can decrease it, increase it, whatever you want. I don't really love how this shape is playing out so far. I probably would have done the first section and the center fuselage together. I kind of think that's a better option. It's all right. Not great. But okay, we'll go with it. Then we'll finish the same thing back here, where you're going from the aft section. Let's do a lofted surface starting at the edge this time so we can get tangent information and going all the way to the back. Green handles are mismatched, so I'll drag this one down. Okay, you have to be sure to set start and end constraints. Start constraint now will be the one that's tangent, so now you see that gives it that kind of angular change here in the back, but I don't want that to be hugely influential. I want the angle to change relatively quickly. So by decreasing the tension, I keep it back inside of that ground strike line, while still keeping it, tangent continuous here at the other surface boundary. So yeah, that's not so bad. I'll say okay. And now we have those parts put together. So it's actually fairly, considerably smaller than the little wireframe sketch we did. At least on the top to the sides, it looks much more slab-sided, and it contains all the elements we need, except a battery and receiver. But I've beat myself up on that one enough so far. So let's close this thing off a little. At which point you'll see. Oh wait, I almost forgot the other party trick I had left. Let's show the other surface option. Now you can see between the two how different they are by doing it in multiple segments, by doing it as a single segment, and of course there are many different combinations that I didn't cover. So, this is where the design and the aesthetic drive of the engineer can take charge. I mean, certainly aerodynamics has to play a role, but we haven't run any of that yet, so you might as well just make it look good at this point and fix the aero problems that happen later. Okay, actually I kind of like the first option, I think, with everything in one. So I'm going to get rid of these three, preserve the teal monstrosity that started this. Yeah, I'm going to carry that one forward. Okie dokie, let's save. Let's close off the front after we do something else. Yes, so I'm going to go back in time a little bit. Right, so before we did the loft, why is this sketch disappeared? That makes no sense. Actually, let's just do this in an easier way. I know the loft is really easy to recreate. Let's just go ahead and delete it. It keeps all the sketches. Everything's rebuilt. Okay, so the loft is easy to build again because it's just a collection of the four. But I'm going to show you how to make it a more controlled loft now. So on the right plane, I'm going to create a sketch that now will define the upper surface all the way from the origin, passing through that point, this point, basically every place that your station lines intercept the right-hand plane, you're going to put this spline. And one outside because we're going to close off the tail as well. And this needs to be a separate sketch for the bottom one. So I'm going to get this shape exactly as I want it, which the only thing I really care about, I think, is modifying that angle somewhat. Oops, that messed up other things. So yeah, here we go. But this, again, is just some of the aesthetic drive of the airplane. Good enough for an example. We'll say okay on that. We want a separate bottom sketch. So we're still in this sub part of an assembly creating a sketch. I'm going to save it because, you know, SolidWorks and crashing, it's a thing. Right-handed plane, make a new sketch. So now you're on the bottom half. And this is for the same reason we do airfoils top and bottom, to be able to select the path top to bottom each, because these are going to become guide curves for the loft. We're going to make this surface pass through these lines, which gives us better control over the shape that's actually generated. So if you're from the side, you can see this one obviously needs some shape control. So let's do that with the handles. Much better to do it with handles than with just numerous additional points. Keep it relatively flat. Need to decrease this so we don't have too much of a belly back here where it should rotate. Change that angle somewhat, and actually I think this point location here is bad. I will just take it up like so. Good enough. All right. So now this time, save, as I'm doing the loft, you can go to Surface, Lofted Surface, and yeah, same thing as before. You select the cross-section, cross-section, cross-section. The handles are lining up nicely. Cross-section. Okay, so that looks just like we had previously. But now you notice that even though it's close to this sketch line we just made, it's not exactly on it until you click Guide Curves, top, snaps directly to it. Oof. Perfect. Right, obviously I have some issues. That's a new SolidWorks failure for me. That's impressive. That's horrible. Wow. Really though, how does... Okay. Guide curve 2. That one. Okay. Did it fix itself? Okay, it did. I think. Yes. Wow, the intermediate thing was really, really odd. Okay. But regardless, there we go. You can also set these up with three-dimensional sketches, which gets a little bit crazy, because right now the thing I'm seeing is that right here around the third or fourth row of passengers, it's getting a bit wide. Right? I mean, aerodynamically, that's pretty good. I mean, it's very smooth. It evolves nicely, but still, you could squeeze a little bit of fuselage fatness out right there, and that might decrease your total width of the fuselage, decrease drag. It might make it worse. Who knows? Do some studies. But anyway, you can add another section if you wanted to. You can go back and revise your design. Oops, not normal too. But this is a pretty good start. Let's close this out by... I guess first we will mirror this across the center plane. Just under features, mirror, mirror, mirror on the wall. Mirror facer plane, so it'll be the part center line. Should be the right plane, features to mirror. That loft, nope, bodies to mirror. We'll do body. Yep, okay. Give me a rough preview. Knit surfaces, that means it'll join the surfaces after they get mirrored across. Let's actually not do that. I'm going to show you that tool here in a bit. So now we actually have just a duplicate of that. It's starting to look much more like an aircraft fuselage. And it'll really look like one once we take this last step. So the front should be fairly simple. Surfaces, let's actually do a... There are a few options, and this is where we get into a lot of debate. And some of the minutiae between CAD programs happens here as well. The easiest thing to do here will be I think it's just a fill. Yeah, just a little patch. CATIA calls it something else, but it's basically the same process. That you see it's connected to the boundary, it's covered the surface, and it only has contact continuity. When we turn it to tangent continuous, it warns us it might not happen, but it has more or less succeeded in putting a smooth-ish Yeah, it's not quite perfect, is it? Putting a smoothish connection between there. Keep in mind, you'll be sanding molds. All these little tiniest changes will apply to all edges. Yeah, that might make it easier. Okay, yeah, we're gonna go with that. You should be able to change tensions. Nope, guess not. But that puts a nice rounded nose on the front. Now, with many of your single motor aircraft, you're not really going to be worried about molding a nose, so what you draw there isn't terribly critical. Because it'll get chopped off, motor installed, propeller goes up front, you're good to go. The back is a kind of a different story here, and I'll show you a different way of making this work. Let's see if I can make this work with what we've just got. Oh, I don't want to make the reference to that outside component. All right, let's go with the right-handed plane. I'll create a sketch just for the piece I'm about to make, where instead of having a bulkhead sketch or the definition of half of the bulkhead, I'm going to take one line and in the very back of the plane do something like this. So close to the angle I want the rudder to make, or the whole vertical tail to make with the fuselage. And then you probably see where I'm going. A lofted surface from 1/2 to a line works. Start with an edge, so we should be able to say start constraint tangent to face. Yeah, I think that worked. Oh gosh, come back. There we go. I think. Yeah, we'll just give it a go. We'll see if we have problems with it. But that looks pretty healthy. Now the thing is, like, it's in the wrong order. I just went ahead and mirrored it, a few steps before, and then did this after. Hopefully, I can just relocate that before. Yes, I can. And now, the reason I can is because it doesn't have any dependencies off of this surface fill or the mirror itself. So that way it can be placed in time before it. You can reorder parts as long as it wouldn't break any sort of hierarchical dependency. So in the mirror now, you click that. Instead of just having one body, you can actually also select this body as well. Both of them get mirrored across, and now we're really close to having a finished up airplane. Airplane fuselage. Let's go ahead and hide these sketches. They're kind of just now getting in the way more than they're helping. You just hide. You don't have to delete them. Just right click and hide in the tree. Even though we're not in the assembly, you can still hide and show them. This is a very oddly shaped fuselage, but we can call it aerodynamic. Certainly it's something that I think should be evolved a bit more before finalized into a molding form. But it's pretty good. You can see that it looks closed, but I tell you that it's not. Surfaces in SOLIDWORKS are defined either with black edges or blue edges, depending on if that surface edge is closed together or open. Since all these edges are blue, which I should save, by the way, it just hit my mind, that means that every one of these is actually an independent surfaced body. You can see this underneath surfaced bodies, which, notice we don't have any solids in this. We have 1, 2, 3, 4, 5 surfaced bodies. Now they match up to one another very, very well because we used these surfaces to create others. So it should be fine. Know that we probably maybe will have some difficulty back here because it's infinitely thin, but we'll solve those problems when they come. You could include some thickness there if you felt like it. Let's go ahead, however, right now and just finish up this video by saying knit. Knit surface is how you join these multitude of well-behaved, edge-compliant surfaces with one another. You just go around and click on everything you want to join up, and this is actually a very good thing because we got the option to create a solid from these. That means that it's a watertight set of surfaces, meaning that if you actually did fill this up, there wouldn't be any leaks, there aren't any gaps. And this gap control tool, if we had substantial gaps, like inches wide, it wouldn't do anything. But if you are dealing with mathematical errors in SOLIDWORKS where the gap is at such a small scale that it's just maybe the difference in interpolation, the difference in spline, something ridiculous, this will help close them for you. I don't want a solid, but we will just go ahead and say knit the surface together. Now those blue lines have turned into black and the number of surfaced bodies decreased to 1. This is a very critical and important operation for future things we're going to be showing in videos. But right now, that's a decent example of a fuselage. This should let you draw everything from general aviation aircraft to fighter jets in very simple form.